So in this related rates problem, we read that a 50-meter rope is tied to the back of a truck such that it is 2 meters above the ground. So that's the point where it anchors to the truck there. The rope is passed over a pulley 20 meters above the ground, and the loose end is connected to a weight, okay, of some sort. If the truck drives away at 10 meters per second, how fast is the weight moving upwards when it is 8 meters high? Okay, so we got to look at what we know here. And this particular problem can be a little bit confusing here. So what we're doing here is, here's the back end of this truck here, okay? So whatever, my diagrams are going to be terrible, but you're going to get the idea. This will give you roughly what's going on here. So here's that end of the rope tied to the truck, and it's going to go up over our pulley, going to come down, okay? And it's going to be attached to a weight. So here's what we know. We know that this distance right here is 2 meters. I know that this distance over here is 20 meters. Now, I'm sorry, that's going right down to the ground there, because that pulley is 20 meters up. Which means, and this is the important part right here, what I'm going to do is I'm going to draw the little triangle right here just to fill that in. So what this means is that this distance right here is going to be 18. Okay, 18 meters. Because it's remember, this is 20 meters, the pulley's 20 meters off the ground, and this thing is 2 meters up, so that leaves 18 meters right here. So now let's throw some variables on here. This is going to be x, let's say that this is going to be y, and this is z here. Okay? Now, the truck is going to drive away at 10 meters per second. Now, let's think about that in terms of this triangle right here that we've built. What variable is that that's changing? Which one of these variables is going to correspond to the truck moving? And I hope it's clear that it's going to be x, because the truck is going to move this way, x is going to be the one that increases. Now, granted, z is going to increase as well, but it's going to be directly x here in this triangle. It's going to be changing directly proportional to the speed of the truck. So dx by dt is going to equal 10 meters per second. Okay? Now, in terms of this triangle here, and I know this is going to be a little bit confusing for some people here, but just kind of hear me out on this one. In terms of this triangle right here, just ignore the weight for right now. Essentially, the purpose of the weight, quite honestly, is so that we get this nice triangle forming. That's it. This rope, it goes straight down. It's not flapping in the wind or whatever. There's a little bit of weight to it, so it holds it straight down. So as the truck moves, this is going to stay taut. It's going to continue to form this triangle right here. So in terms of this triangle right here, as this point gets pulled away, notice that this side right here is always going to be 18. Okay? Basically, the distance from the top of the truck, the bed of the truck here, up to that pulley will always be 18 meters. And granted, I know, that weight is going to fly up, and sometimes it's going to be up here, and so that distance is going to be smaller, but that's actually not what I'm interested in right now. I am only interested in how the truck is affecting this triangle here. I know how this is going to change. What I'm kind of interested in is how Z changes. Now, let me kind of get to that point here, and I'll explain why it's more interesting as to, what we're more interested in is why Z is changing as opposed to what's going on over here. So the equation that I'm going to build here will be x squared plus 18 squared will equal z squared. Okay? Now, I also know, I should say here, that I've got 50 meters of rope. 50 meters of rope here. Now, we're going to see how that plays out in just a second here. Okay, so let's take a look at, okay, let's just jump into it here. So what we want here, what I want to know how fast the weight is moving upwards when it is 8 meters high. Okay, so I want to know dy by dt. Well, actually, you know what? I think that's going to be confusing for people. It's not dy by dt that I want. Okay, it's really not dy by dt that I want. Because now y represents, in this case here, just the height of that triangle. So let's just get rid of that because we know that's going to be a constant. The weight is going to fly up into the triangle and then beyond here. So it's going to keep going here. But now think about how fast is that weight going to move? Well, remember there's 50 meters of rope here. So essentially it's going to go up at the same rate that Z is increasing. So every time I pull this out, if Z gets longer by 1 meter, this distance here gets shorter by 1 meter. Okay, if Z gets longer by 3 meters, this gets shorter by 3 meters because there's only 50 meters of rope available. So really what I want here is dz by dt. Because however this changes right here, that's going to translate into a change in the height of that weight. And so now let's get into this here. So x squared plus 18 squared equals z squared. Okay, I will take the derivative and I'll do it implicitly with respect to time. So 2x dx by dt. The derivative of the 18 squared is going to be 0. 2z dz by dt. So now I'm going to bring the dz by dt over. So this will be, whoops, sorry. Don't know why I wrote that. dz by dt is going to equal, the 2's will cancel, we'll get x over z dz by dt. Okay, so there's my relationship right now. Oh, sorry, why did I do that? I'm just confusing myself now. That's dx by dt. I'm isolating the dz by dt, so that's going to be in terms of dx by dt. Okay, so now what I got to do is I got to figure out the little bits of information here when the weight is 8 meters up. Okay. So now let's maybe redraw this right here. So here's the truck, okay? There's the ground right here. Here's our pulley. This is going to go up and over. Now here's the thing. What we're interested in is when the weight, that moment when the weight is 8 meters up. Now we know that this distance is supposed to be 20. So that means right here, how much rope is left hanging right here? Well, the answer is it's got to be 12 meters. Okay? That's got to be 12 meters. So yeah, 12, 8, 20, there we go. If that's 12 meters, how much of this is left over? Well, that's going to be 38 meters. So we're looking at this instant here. Okay, we're looking at the instant here where Z is going to be 38 meters. Has to be 38 meters because there's 50 meters of rope. Now, the question is how far over has the truck gone? What is x? Because for my dz by dt, I need to know what x is and I need to know what z is. Okay, so, I mean, right now I know that z is going to be 38. I know dx by dt is going to be positive 10. What I don't know is x. But I can figure that out here because remember, it doesn't really, I mean, it mattered because I used it to figure out what z is, but in terms of this triangle, it doesn't really matter where that weight is. This part of the triangle stays the same. This is 18, here's x. I'm still looking at the triangle that's built here, even though the weight is above this mark. And so now I can just use the Pythagorean theorem for that. X squared plus 18 squared is going to equal 38 squared. So now I'll just go to my calculator. 38 squared minus 18 squared. It's going to be 1,120. Okay, now I'm going to take the square root of that. Now I highly doubt that's going to work out nicely, and it doesn't. So 1,120, divide that by 4. Okay, and so what we're going to get here that is x is going to equal plus or minus the square root of 1,120. And that can be reduced to plus or minus 4 root 70. Now I'm just going to double check that I did that right. Yep. And I know in this case right here that it's going to be positive. That plus or minus here doesn't make any sense because of the way we've drawn this. So it's going to be, x is going to be 4 root 70. So now come over to our expression here, 4 root 70. So that means dx by dt, now let's simplify this here. That's going to be 40 divided by 38. let the calculator handle that. This is going to become 20 over 19 root 70. What is this? Meters per second. Okay? Now, just to kind of help us get an idea as to what that really looks like, that is going to be approximately 8.8 meters per second. That is how fast that weight is flying up, because that is how fast the hypotenuse of that triangle is changing.